Hi everybody. In this video I'm gonna go over a few questions for your second exam. Actually these questions are from your practice exam and it's a great idea to go over it. So the first question that somebody asked me to solve it is on chapter 4, section 4.3, question number 23. So they're asking us for which values of a and b this function is increasing. So by looking at the function, we are dealing with exponential function. In your note sheet, we have that the graph goes like this if b is more than 1. At the beginning when and we have another one is decaying like this. Oops. And this is decaying or decreasing if b is between 1 and 0. Before we go to the value of b, we said a must be positive. So if a is positive, we have increasing, decreasing. But if a is negative, that means we need to reflect it. For example, for the same graph here, b is greater than 1, the function is increasing. But if a is less than 0, that means a is negative. For example, negative 3 multiplied by 2 to the power of x. So 2 to the power of x is increasing function. But because a is negative, so we have to reflect it to x-axis. Now, when you read the new graph from left to right, the function is decreasing. So the value of a is very important to decide, is it increasing or decreasing? So now back to this example. We are looking for increasing function. So b is between 0 and 1. That means the graph decreases if a is greater than 0. But here they said a is less than 0. So if a is less than 0, this graph will reflect to the x-axis. It will be something like this. So now when we are reading the new graph from left to right, if the graph is going up, so it's increasing. So this is one of the solution. The second one, they said b is greater than 1. That means the graph gonna go up like this. Then a is less than 0. A is less than 0, that is negative, we're gonna reflect it. The new graph is decreasing. So that's not good. Third one, we have b is between 0 and 1. That means the graph is decreasing if a is positive, and a is positive, so this is decreasing. Last one, b is greater than 1, which means this is greater than 1, and a is greater than 0, so we keep it like this. A is positive. If it was negative, we reflect, but it's positive, so we keep it like this, and this is increasing function. So these two will be the solution. We have another question, but now they're asking us decreasing. So they're asking us decreasing. We have no problem. We know this function. B is between 0 and 1. And a is positive. So that means this is exactly what we started. We have b, so a is positive, 0 and 1 is decaying like that. From left to right, when you go, the graph going down. So this is decreasing. B is greater than 1, goes up, and a is positive, so we keep it like this. This is increasing, so that's not the good one for this question. Third one, between 0 and 1, and a is negative. So between 0 and 1 is like this, decreasing. Now a is negative, that means we have to reflect this one, it will be like this. Now when we read the blue one, it will increase. So that's not good. These two are not. And last one, b is greater than 1. That means the graph gonna go up when a is positive, but they said a is negative, so we're gonna go like this, which is decreasing. So again, this 2 is correct. Let's go to another question. Chapter 4, section 4.4, question 18. Word problem. I know you guys don't like it, but try to love it for only next few days. We have three formulas: y equal to a times b to power of x, y equal to a e to power of kx, and y equal to p1 plus r over n to the exponent nt. When you see a word problem in chapter 4, you need to know which formula to pick. The keyword component quarterly, that means we are dealing with n equal to 4 for this question. So we are using that formula. This p is initial value, and this y or b, whatever you want to call it, as a value after a few years. In this case, after 6 years. So we're going to use that formula. So I'm going to say, so we have $600 is invested for 6 years, become $1,200. So 1,200 equal to, so 600 is initial value, 1 plus, we are looking for r, n is 4 to the power of 4 multiplied by 6. Exactly this formula. N times per year, this is quarterly, that means n equal to 4, T6. We are looking for the R, annual rates. So initial value, this P become 1,200 after 6 years. So we have enough information to solve for R. So it's very advanced algebra here to get the R. I divided by 600, so we get 2 equal to 1 plus R over 4 to power 24. So now we need to have R by itself. I don't have a calculator here, but first we have to get rid of this 24. I make to the exponent 1 over 24 to get rid of this, and exponent 1 over 24. So we have 2 to the power of 1 over 24 equal to 1 plus r over 4. I subtract 1 to both sides. We have 2 to power 1 over 24. So you need to calculate this. Minus 1 equal to r over 4. Then I multiply by 4 both sides. Then r, which we are looking for, equal to 4 parenthesis 2 to the power 1 over 24 minus 1. So I don't have a calculator. This will be your r. If they said decimal, you leave it at decimal, but if you said percentage, you will keep it in percentage. For example, if you said if r equal, for example, if you got r equal to approximately something like a 0.01, for example, or 1, you will make this one 1.1%. Looks like they wanted percentage, so you have to move the decimal two digit here. So you need to follow how many decimal they asking. All right, let's go to last question. They're asking find the formula for the find the possible formula for the exponential for the using find the possible formula for the function using logs or exponential. I know I haven't gone over the graph of log first, but this what we see here, this is the graph of exponential. This is a multiplied by b to power of x, and because it's growing, so this 0.25 is a. So without looking at those choices, what we see here, well, what we see here, a is 0.25. We have no idea about b. I'm going to b to power of x. But this b, by looking at the graph, b should be more than 1 because it's increasing. So this is what I see. Okay? That's what I see. Let's go to the choices. First one, 0.25 b to power of x is exactly what I have. But they said b is between 0 and 1. So b is between 0 and 1, that means it's going to decay like this. So that's not good. 0.25 to power of x, well, no. We don't have b here, and this is out. Or you can just try, say x equal to 0, you're going to get 0.25 to power 0 is 1. But at 0, we have 0.25, so this is out. And this one, if you put 0 for x, you get 1. Again, we're not going to get 0.25. Also, this is 4. Initial value is not correct. Last one is a good candidate. 0.25 for here. B, they said is more than 1, is increasing. And x, that's what we love. So the last choice is going to be a correct choice.